Tonight's video is the first one of our new weather unit, and we're going to look at the water cycle, which should be a review for most of us from 5th grade, and then this concept of relative humidity, which is going to look at the water vapor in the air. So to start off with a quick review, we're going to talk about the water cycle. This shows the movement of water through the Earth's atmosphere, so from the surface as lakes and ponds, up through evaporating into the atmosphere, condensing, raining back to the surface, either as rain, snow, other forms of precipitation, and then ending up back in either our lakes or ponds or our groundwater. So we can define the water cycle as the movement of water through the atmosphere and it's got 4 steps that we're going to need to know. We've got evaporation, where liquid water becomes a gas. We've got condensation, where that water vapor becomes liquid again. Finally, next we have precipitation, where these water droplets combine and fall to earth. And then finally we have one of 2 choices. We have runoff, which is where water flows into lakes or rivers on the surface, or infiltration, where water soaks into the ground and ends up underneath the ground in what we call groundwater. So water flows into lakes, rivers, or groundwater. And these are our steps of the water cycle. So you can see we have evaporation from oceans, lakes, and streams. We also get this from living things. It's got another name, transpiration, but we're just going to group it with evaporation for our purposes. So all this evaporation goes into a gas. It condenses in the atmosphere and forms clouds, which are tiny liquid droplets, and we'll talk more about clouds tomorrow. These clouds combine. When these water droplets get too big, they combine and fall to earth. We call that precipitation. And then we hit the surface. We have surface runoff to lakes and rivers, or it soaks in and goes to groundwater. So that is the water cycle. And we're going to come back to that a whole bunch throughout this weather unit. And there we go. All right, so the next thing we're going to talk about tonight is something called humidity. And this is something that you all are familiar with. You know, we live in Atlanta in the summer. You guys all know what humidity is. I'm not worried about that. But we're going to talk about how we measure it. So humidity is defined as the amount of water vapor in the air. If we have more water vapor, we have more humidity. And that makes sense. More water vapor, you've got more humidity. And then it turns out that warmer air can hold more water vapor than cold air. And if you think about your experiences with humidity, this should make sense. Right? When does the air feel the most humid? During the summer. Right? During the winter, when the air is cold, the air can't hold a lot of water vapor. You tend to get really dry lips. You have to use more chapstick. You have really dry skin. Whereas in the summer, you can feel the water vapor in the air because there's more humidity and the air is able to hold more water. So we don't really hear, when we talk about humidity though, we always hear it expressed as something called relative humidity, right? And if you hear that, the humidity is 75%. And so relative humidity, it measures how much water is in the air. So water in the air compared to the maximum amount the air could hold at that temperature. And this is a little confusing. We're going to do some diagrams to show what this means. But relative humidity is how much water the air has compared to how much it could hold at that temperature. And this is expressed as a percent. So we can say, for example, say 1 cubic meter of air, so that's a cube 1 meter on a side, so roughly a yard on a side, could hold 10 grams of water vapor at most. That's the most it could hold. If there's only 5 grams of water vapor in there now, 5 out of 10 gives us 50%. Right? And then we would say that the relative humidity of that air is 50%. Here's a diagram for those of you who, like me, are very visual people. Let's say the box in this picture represents the maximum amount of water that the air could possibly hold. So maximum amount of water possible in the air. The blue dots represent the water vapor actually in the air here, which would give our relative humidity of about 50%, because we can see that the box is about half full of water vapor. Right, so we could have more water vapor in the air, but right now we're at about half full, so we would say that the relative humidity here is 50%. Now, relative humidity can change, and there's two ways to change it. We can have more humidity or less humidity. We can either change the amount of water vapor in the air, so change the blue dots, or change the temperature. And this can be a little bit more confusing, but when we change the temperature, we're changing the size of the box. And I'm going to show two examples of that in a second. So we can, if we increase the water vapor in the air, we have an increase in relative humidity. And that makes intuitive sense. If relative humidity is measuring the percentage of water vapor in the air, if I have more water vapor, I'm going to have more relative humidity. That one's pretty intuitive. But it turns out if I increase the temperature as well, I actually decrease the relative humidity. And the reason for that is that warm air can hold more water vapor. So if I increase the temperature, it means that the air could hold more water vapor than it's holding right now. So its relative humidity, its fullness, goes down. And we'll look at this in an example right now. So let's look at our first one. We said the one way to increase relative humidity is to increase water vapor. And so again, the box represents the maximum amount of water possible. Blue dots represent water vapor actually in the air. Right now the relative humidity is 50%, but what if I add more water vapor to the air? Right? And so I'm adding, there's more evaporation going on, and there's more water vapor getting added to the air. What happens now? What would the relative humidity be? Right now the box is totally full of water. I can't add any more water. So now my relative humidity would be 100%. I haven't changed the size of the box, but I've just added more water to fill up the box even more. So I've got a relative humidity of 100%. So that's pretty intuitive. If I were to take water away, ta-da! If I were to take water away, I would decrease my relative humidity. So right now my relative humidity might only be 25%. I'm only a quarter full. Let's look at the other way we can do this. We can also change the temperature of the air. So here the water, the amount of water, the blue dots, is going to stay the same. But let's say I cool down the air. Right? We saw over here warmer air can hold more water vapor than cold air. So if my air is colder, that means my maximum amount of water vapor is going down. So my box is shrinking. So if my air gets colder, my box has shrunk. I can't hold as much water vapor. What's my relative humidity now? It's back to 100%, because the air is totally full of water vapor at the temperature it's at now. It can't hold any more water vapor right now than it could hold. If I made the temperature hotter, that makes my box bigger. Right? So if the air heats up, I've got even more, and this is, I don't know, we'll estimate 33%, right? This is roughly a third full. So now, again, haven't changed the amount of water in the air, but by messing with the temperature, right now it's hotter, the air could have more water vapor, so the relative humidity goes down. So water vapor goes up, humidity goes up, temperature goes up, humidity goes down. those are our big takeaways. All right, make sure you write a summary at the bottom of your notes and fill out the survey on the website, and we will discuss this and do some demos in class tomorrow.